As Borbal already told you, my goal here is to showcase our modeling, connecting to the previous speakers. It's always an interplay of markets and regulation, which is really interesting for us. There has been a lot of concerned voices on storage obligation in the recent months. As Borba told, that the current obligation requires storages to be filled to 90% by the start of withdrawal season. There were some discussions in the European Parliament to ease this target to 83%. We all know that the market-based storage activity is strongly driven by forward market expectations. So basically the winter and summer spreads. So whenever the forward price of gas in the winter is more expensive than the forward price of gas in the summer, it is worthwhile for market participants to store gas. Whenever this relationship changes and it is more expensive to procure gas in the forward summers than you would get in the forward winters, there is no business case for it. And without additional regulation, the utilization of the storages may remain low if the spreads do not support this injection activity. In the recent months, there has been two opposing viewpoints. One of the market distortion coming from the traders, energy traders, Europex or Eurogas. They have voiced their concerns that the storage obligation should be subject to a thorough impact assessment to evaluate all the economic market implications before prolonging it. On the other hand, the European Commission, DG Energy, had their evaluation that the obligation itself is a really useful tool. It is pushing down prices, reducing volatility, and we should keep it. And the question is, where are we in between these two really opposing standpoints? And well, my or our approach to such questions is always to use some kind of stylized modeling. And with that, I will show you how the storage obligation itself affects the utilization of storages, the fill up, how much we use these facilities. And I will try to show how much it costs for the traders and how much benefits it brings to the consumers and whether it's a good regulation or not. So without further ado, if we go back to before the crisis, you can see on this chart the fill-up rate of EU27 storages by the 1st of November, so the start of withdrawal season. You can see how much gas the traders stored in the storages before the obligation, where there was no regulation apart from some state regulation, no overly EU-wide regulation. You see that the traders knew what to do. They filled their storages up to around 90%, sometimes even higher. The market dictated how much gas we stored in each season. Come 2021, we all remember that European located Gazprom storages were not filled as usual, and it caused a really low utilization of the storage infrastructure. This prompted the regulation, first with an 80%, then with a 90% target, and this caused the high utilization what we could see in the subsequent years. But the main question, or the million-dollar question here, is that what happens if we do away with this obligation? What will be the fill-up rate? Do we go back before the crisis levels? So can the market deliver, or do we need this regulation? So that's the question we are trying to answer. And how do we answer this, and why are the fears there? The fear is there that because the summer-winter spreads, which have been positive since 2023 up to the first 3 quarters of 2024, have turned negative. This means that the market players have no financial incentive, no economic incentive. It is not rational to store gas in the storages if these spreads remain negative. The question is what will happen in the future? Do they support the injection activity? And how do we answer this question? Well, we have an in-house natural gas market model. Without all the details, what this model does, it brings as a solution of the European gas market, where the gas bill of the consumers is minimal, and in the same time, the traders and the market participants in the gas market are at their money as well. So it's not only a cost minimization, but also it is taking into account the profitability of traders and also the infrastructure operators. Model takes into account all the infrastructure constraints on pipeline, LNG storage infrastructure, as well as the tariffs and the regulation part. And we also consider long-term contracts, which bring another layer of complexity. But altogether, what this model can do is to show you what the supply structure of Europe is and what are the prices for wholesale gas. And this brings us to indicators that can show you how much the consumers are paying for gas and how much the traders are using the storage infrastructure and so on. But of course, all models are as good as they can represent reality. And before jumping in to this question, what we always do is to calibrate and validate our model, how well it replicates reality. And on these charts, you can see with the red and blue lines, the red showing the modeled outputs and the blue lines showing the historical data. And you can see that we are quite well representing the consumption, the production, and the storage utilization in the EU, as well as on the bottom right, you can see that the model itself represents the European supply structure quite well. So the LNG, Russian pipeline, Norwegian pipeline sources, we modeled for 2024 April to 2025 March, are at the same level as we could observe last year. So once we are quite convinced that we can trust the model, then comes the, well, for me, the fun part of the modeling, where you can start playing with your assumptions and start formulate this problem of the storage obligation for the model itself. And for this, I think there are three main dimensions we should consider. One, as I told you, is the expectation of market participants, the expectation of traders on the summer and winter spreads, whether it is worth to store gas based on the forward prices or not. And we represent this by the expectation of negative or positive spreads. So on negative spreads, it is not worthwhile to store because winter months are cheaper than summer months. With positive spreads, the summer months are cheaper than the winter months. The other layer is whether there is an obligation or not. Of course, if there is no requirement, then market participants will decide on their storage activity. Whenever there is an obligation, then all market players need to store at least 90% of the capacity in EU27 storages. And another layer, which is quite important for Europe right now, as we have moved away from pipeline gas and LNG has become the main source of supply for European gas market, it is really important at which cost and at which price is LNG available for Europe. And we proxy that with the so-called JKM indicator, that is the Japanese Korea marker, at which price Asian markets are willing to pay for LNG. And for this, we indicated three distinct price levels. The current one is 40 euro per megawatt hour, and we indicated a before crisis case, low and oversupplied LNG market for 20 euro per megawatt hour, and the high, which represents, well, not the peak of the crisis, but a little bit higher price level of 60 euro per megawatt hour. And this brings us to, well, a number of scenarios. And this number of scenarios, we can see how it affects the utilization of storages. On these two charts, what you can see, how much EU27 storages are used, how much gas we can find in the storages. And on the right-hand side, you can see the case when the spreads are positive. So when market participants are willing to store gas because it is more expensive in the winter than in the summer. On the left-hand side, you can see when the spreads are negative. The two types of line, the solid lines are showing the with obligation case, and the dotted lines are showing the without obligation case. And what is curious at first and interesting, I think, that in the case of positive spreads, you see little difference between the solid and the dotted line. It means that if the spreads are positive, market participants know when to store and know where to store. They even know better than the obligation because it's really not tailored for every market, but market participants can decide and know better when to store those gas volumes. Whenever there is no positive spreads, on the left-hand side, we are on the negative spread case, we see a really big difference between the dotted and the solid lines. It shows that when there is no obligation and the spreads are negative, then market participants are using storages not up to 90, but up to 60%. And this is quite a big difference, of course, but what does it cause? As I told you, our model is able to simulate or show price outputs as well. On this chart, I'm showing you in the same logic of positive and negative spreads, the German average annual wholesale price. And whenever the spreads are positive, there is little difference in between the two scenarios. On the blue one with the no obligation, the orange one with the obligation case, the prices are basically the same. Whenever the spreads are negative, it's really interesting that the obligation itself has a price decreasing effect. Why is that? The obligation itself has two kinds of price effect. On the one hand, it creates an additional demand in the summer because you need new volumes of gas to be stored. On the other hand, these new gas volumes are there in the winter, and this is pushing down the winter prices. And on an annual average, this is overly a positive, a price alleviating effect, depending on the global market scenario. This 20, 40, or 60 Japanese price, it's an effect of 0.2, 0.7 euro per megawatt hour on the German market. The price effects are really similar for all the EU27 countries. And having this price and volume effect, what the model can bring, or what we can also calculate, is the overall benefits of this obligation. On the benefits side, we have this price alleviating effect and bill saving, gas bill saving for the consumers. But of course, on the cost side, we have additional storage fees to pay for the additional storage activity, and we need this additional cost of gas to be stored. So that's on the cost side. And what is really important, that the benefits are not really realized at the same market participants or the same stakeholders, because the benefits are at the consumer side, the costs are at the trader side. Of course, if markets work perfectly and there are low transaction costs, it will just even out. And overall, if the benefits of this regulation are outweighing the costs of the regulation, we can say that, well, then it's a nice regulation and we should keep it. Whenever the costs are over the benefits, well, we should think about it. And what is the answer for this? Well, I can only give you a boring economist answer that it depends. It depends on the scenario. It depends whenever we have positive spreads or negative spreads, and it depends at which price LNG is available for Europe. With the positive spreads, what is curious, that it's mostly so the two charts are showing the benefits and the cost. Benefits are with blue, the costs are with orange, and these little diamonds or points are showing the net of these two. And you can see that if the spreads are positive, then this net is mostly negative or close to zero. On the left-hand side, when you are at the negative spreads, what you can see that the dimension of both the benefits and costs is much higher. And whenever the market is scarce, whenever the LNG is expensive, the benefits outweigh the costs. Whenever we are at €40 per megawatt hour, they are close to zero. Whenever the market is oversupplied, then the costs are outweighing the benefits. So overall, if we expect that markets are to be tight, it is good to have such an obligation. If we expect markets to be oversupplied and there is LNG available at a low cost and there is no scarcity, then we do not need such an obligation. We do not need such an insurance. And also, if the spreads are positive, so market participants know and expect a positive return on their storage activity, they usually know better when to store and where to store than a one-size-fits-all regulation which says that all storages need to be filled at 90%. So I think that's a really important point to make. And to conclude, well, did I answer that should there be an obligation or not? Well, partly it depends on the circumstances. With an oversupplied market and low LNG prices, the obligation may be a bit more costly to upkeep than let the market players decide. But still, you need the positive spreads of winter and summer to make this a business case. If these spreads are not there, then it is worthwhile to make the regulation and keep the regulation with the tight LNG market and higher Japanese prices. It is clearly beneficial and serves an insurance. And to my understanding, and if we are following the market, we see that of course, huge volumes of LNG are coming online by 2027. But until then, we are in a tight market situation. And it can easily happen that the price level is higher and closer to the €60 per megawatt hour scenario than to the oversupplied €20 per megawatt hour. And the other thing to point out is that the cost of this building and maintaining this additional stocks, it varies between 0.2 or 1.5 billion euro, depending on the scenario, of course, for the EU27. And if you want to compare this number to something, well, the total gas bill of the EU, if you are just saying that multiplying how much gas EU consumers are using at the average price of around €40 per megawatt hour, well, comparing to that number, this additional building of the stocks is around 1%. So I'm just asking whether it's worth to put an insurance of 1% to make sure we are not in a really high price situation and not creating really big losses. Or not, but I think that it is clearly a case for an obligation to be there until the markets rebalance again and until this oversupply in the LNG market appears. So I finish here. Thank you very much.